I'm working on a 2D isometric mobile game called Allete. Allete is this super chill puzzle game where you're a cube who can split to form smaller cubes and combine with other cubes to form bigger ones. I originally created it for the Brackeys Game Jam 2021.1 and I really enjoyed working on it, so here we are. The jam version had a few bugs and I had an idea for a better art style. So this week I started remaking the whole thing. I of course started with a bit of planning. In the past I've used Trello for this kind of thing. I even made a video on it which you should probably go watch. But this time around I decided to use this website called Codex. I'm not really going to talk too much about Codex in this video because I had that planned for a future devlog. Anyway, when that was done, my first task was to redraw all the art. But before that, I needed a color palette. The jam version of the game used a palette I found on low spec. And the palette looked good, but it didn't really have that many colors and I kind of want to go for a different atmosphere. My solution of course was to try and learn how to make a custom color palette. So I did a lot of research and eventually came up with these 3 colors that form a split complementary color scheme. Split complementary just means you pick 2 complementary colors and then you replace one of them with its 2 adjacent. I then really just experimented and figured out what looked good from there. And I ended up with this, which I'm really proud of. Now, most game devs I know prefer to get the basic game loop working before they even start on the art. Personally, I don't do this because it really motivates me to work on something that looks good. So of course, I got working on the art. In the devlog for the jam version, I already explained my process for isometric art, but I'm gonna do it again. First off, I make the isometric grid. To do this, I use Illustrator's grid tool to make a regular grid. I then rotate it 45 degrees and scale it down to 57.74% on the y-axis to get the isometric perspective. And unlike the jam, I saved it as a template this time so I don't have to constantly remake it. Now, an isometric grid is cool, but if you don't actually draw any isometric shapes, there's no point. So all I really do for this is just draw on the grid lines and we get cool isometric shapes. Adding shadows is also pretty easy. In the case of the block, all I do is duplicate whatever side, change its color to a transparent black, and then overlay it on top of its corresponding side, which makes it look like a shadow. And I, of course, save this isometric block as a template. Now it's super fast and easy for me to make art. I started by making the game's background, which is just the first 2 colors in the palette in a gradient. I then moved on to the ground tile, which I based off the template that I made earlier. I also used this really helpful tool in Illustrator called the Shape Builder tool, which I used to cut off this squiggly thing on the ground tile. When that was all done, I made the big and small players, which I made orange and pink to make them stand out. In the jam version, I only had a big and a small player, but in this release, I'm going to have a few more, I think. In the jam version, I also had a system where the blue player couldn't walk on green tiles and the green player couldn't walk on blue tiles. I want that system in the full game, so I added a pink tile which only the pink player can walk on and drew an orange tile which only the orange player could walk on. I also drew a tile that the player lands on to beat the level. I made it look a lot different than all the other tiles so that you would actually notice it. And to finish up all the art, I made this isometric sphere which I'll probably use for particles or something. Alright, now that the art is done, it's time for me to move on to my next task, which is rewriting all of the code. And I, of course, started with the movement. The way I went about doing this is really similar to what I did for the jam. I have this base movement class, which takes in a direction to move the player. In the jam version, this was a vector 2 that held the WASD inputs. And because I'm releasing this game for mobile devices, it doesn't really make sense to use keyboard inputs. Instead, I think I want to have the player slide in whatever direction they want to move. But 99% of the playtests for this game are going to be on my laptop, so for now I'm just getting the direction to the mouse. I then take that and round it to the nearest isometric direction, which gives us this ugly but functional movement. Now, a keyword in the phrase ugly but functional is ugly, and players are gonna want to play an ugly game, so I kind of have to fix that. And I, of course, fixed it by adding in some cool animations made with DoTween. And now it doesn't look terrible, which is pretty cool. If you're observant, you'll notice that the player has been glowing this whole time. But what's interesting about that is that there's no post-processing in my game, hence there's no bloom. Instead, I'm using the Universal Render Pipeline's 2D lights. In this case, I just have a freeform light shape to fit the player. And speaking of 2D lights, it's time for me to move on to something that's completely unrelated to 2D lights. I'm of course talking about the main premise of the game, which is splitting and combining. The idea is that the orange player will split when they touch the orange spike, and same with the pink player but with the pink spike. This also means that the orange player can't go on tiles with the pink spike, and vice versa of course. And to accomplish all this, we need spikes. So I quickly drew one in Illustrator using the techniques I talked about before, and it looks pretty cool. Anyway, in the jam version, whenever the player moved, I was doing two checks. The first check was to check if the tile that they wanted to walk on was actually walkable. Because if there's a pink tile or just no tile, then the orange player is not going to be able to walk there. Obviously, Obviously, same with the pink player except with the orange tile. The second check was to see if there was an obstacle on that tile. And for other reasons, my spikes, which were the only obstacles, weren't actually on a tile map, meaning that I'm also doing a physics check every frame alongside that original tile check. Besides the fact that this isn't performant, this is just really complicated to maintain. So I found a really cool solution to this. I have my spikes as game objects like before. I then snap their position to the grid and then disable their sprite renderer so that they're not showing. I then add a spike tile in that position to the obstacle tile map. To show proof of this working, I can actually move the spike game object wherever I want and it won't do anything to the tile. The advantage of a system like this is that I can attach whatever scripts and components I want to whatever tile. Right now the spike just has a script in a box collider, but the possibilities are endless. To sum this all up, instead of doing a physics check and a tile check to check if the next tile is walkable, I just do 2 tile checks. This makes my code a lot shorter and easier to understand. So now we have obstacles. Obviously the orange player is supposed to split on the orange spikes, but this is just for testing purposes. Just pretend it's the pink player. And with that, it was Friday, so I had to start editing this video. My goal is to keep uploading weekly devlogs, but occasionally I'll take a week off or 2 just so that I can make more progress on the game. And like I said earlier, my goal is to turn this into a mobile game and publish it on the App Store and Google Play. So if you're interested in keeping up with that, well, stick around. So yeah, hit like if you like, also hit like if you dislike, and please subscribe. And have a great day.